So that's section 5.4, exercise 14. A farmer was interested in determining how many grasshoppers were in his fields. He knows that the distribution of grasshoppers may not be normally distributed. If the population is not normally distributed, remember guys, the sample size has to be more than 30 in this field due to growing conditions. As he drives his tractor down each row, he counts how many grasshoppers he sees flying away. After several rows, he figures that the mean is 57 and the standard deviation is 12. What is the probability that the farmer will count 60 or more flights on average? That means the sample mean on average in the next 40 rows. Can someone tell me what does 40 stand for? What symbol would 40 be used for? What do you guys think? And yes, very good. And he wants actually probability of X bar is greater than or equal to 60. Now, why did I say X bar? Because he says on average. On average means the mean, the sample mean. So probability of, you don't have to put the equal sign, either greater or less than. The equal sign doesn't mean anything in the continuous case because there is no such a thing called exactly 60.
So where'd you get 60?
Because he says, what's the probability that he will count 60 or more? 60 or more means bigger than or equal to 60. I could have made it easier. What is the probability that the farmer will count more than 60? Then you would have guessed right away it's a greater sign. Okay, how did we do that with a normal CDF? Greater than 60. So you start with 60. That's the lower bound. What would be the upper bound, guys? Still remember the magic number?
1 million.
1 million. And then the mean, which is 57. The only thing here, you just have to pay attention because the question is about the sample mean. It's not sigma, it's sigma over square root of n. So it would be 12 divided by square root of 40. And that's the only difference between this section and the previous sections. When you have a sample size, the standard deviation is called the standard error of the mean. You have to divide it by square root of n. So that will be second and distribute, normal CDF, lower is 60, upper is million. Just put as many zeros as you want, 57. 12 divided by square root of 40. You see, I can have the calculator do the math. You could do this separately first, but you can just plug it in, no problem. And enter. And here's the 69.
So why did we do 12 divided by the square root of 40 at the end?
Because the question is about the sample. When the question is about the sample, we don't use the original population standard deviation. We use the standard deviation divided by square root of n. Always. Anytime there is a question about X bar, less than, greater than, etc. When you do the normal CDF, you put sigma and then divide it by square root of n. And that's what we concluded last time when we did the central limit theorem.
Mr. Bazzi,
Mm-hmm.
how did you plug in the formula that the square root? Because I tried to do it, but I need to do it separately because it didn't work for me.
No, it should. Let me show you. So second, distribute, normal CDF. I'll show you my the keystrokes. So 60, no problem. The upper, I'm guessing, no problem here. Okay, here, let me delete it. 12, then the division sign, yes. And then press the second key and then go to square root, which is x squared right here. And put the number, which is what, 40, and close.
Oh, okay. So after the division sign, I have to press the second, then the x2, and then enter the number.
Exactly.
Got it. Thank you.
Yeah,
So that formula with the standard deviation divided by the square root, that's only if there's if the question talks about a sample, right?
100%. You are correct. You nailed it. When the question is about the sample mean, yes, definitely. You cannot use sigma. You have to use sigma over square root of n. That's what the conclusion of section 5.4. So in other words, if the population of X, just the original population, looks like this, the distribution of the sample looks like that. So if that has a sigma, look, this is a narrower curve. It has a smaller standard deviation, which is called sigma over square root of n. So always the case. We'll get to do some more exercises anyway in a little bit. So okay, here is a summary, guys, of using the calculator, the two main features. It's in your guided notebook, Normalcdf and inverse norm with some examples. I'm not gonna go over them because they're worked out with screenshots. So you can use them later, but what I'm gonna do is I'm just gonna do the general review of chapter 5 right here. So I am making the assumption that everyone knows how to plug in numbers into the calculator and use the Normalcdf or the inverse norm, the two functions on the calculator. So more practice using TI-84. Probability of Z less than 1.14. So when it is a less than, we agreed, guys, we start with this. Then we put 1.14. And if it is a Z, remember, the mean is 0 and the standard deviation is 1. If it doesn't give you a mean and standard deviation, be assured that it is a 0 and 1. And just to do it, second and quit, second and distribute, Normalcdf. So that's a negative a million. What did we say? Probability of Z less than 1.14, 1.14. And look, by default, it's 0, 1 anyway. So 0.8729. And if you guys wanted to use the table, you could. I mean, if you try to get help from the book online, it's going to show you how to use the table, probably not the calculator for sure. You want to see the 1.14? This is the 1.14. Watch, guys. Oh, not this one. Right here. 1.14, 1.1 right here. And then I need the 4 right there. And here you go, 0.8729, guys. It's exactly the same thing as I rounded. So the table can be used as well. Number 2, find the probability of Z less than 0.34 or Z greater than 1.24. The or means a plus, guys. So you have to do probability of Z less than 0.34 plus probability of Z bigger than 1.24. Okay, I already guided you through to starting this one. So Normalcdf will be for the first one, negative a million, 0.34, comma 0, comma 1. And the second one, guys, it will be what? 1.24 to begin with, then a million, then comma 0, comma 1. You just do each one and then add the answers. Find the area to the left of Z equals 1.09. To the left of Z equal 1.09 means less than. So to the left of means a less than, to the right of means a greater than. And can someone tell me what would be the 4 arguments here, guys?
Would be negative, no, 1.09.
No, you started right. It's less than. So negative a million. Then what? 1.09. Then 0. Then 1. Even if you put negative 1,000, it will work. So let me just give you the answer for this. So negative 1,000,000, 1.09, 0.8621. Okay. Number 4. Now he wants the z-score. He gives you the probability and he wants the z-score. It's an inverse norm. 74th percentile. 74th percentile means 74%, guys. So here's what he wants. That is a 74%. A 74th percentile means 74% of the data is below that number. So that's the number that he wants. We wants that number, z. So that will be inverse norm. The inverse norm requires the 3 arguments, guys. Requires area to the left, and requires a mean, and requires a standard deviation. The area to the left for percentile, it is the percentile that he gives you. That will be 0.74. And then since it is z, guys, we know the mean is 0 and the standard deviation is 1. So that would be inverse norm 0.7401. Anytime he gives you a percentile and asks you to for z-score, just put that percentile here and put comma 0.1. So let's see. Second, distribute, it's going to be inverse norm. Area is 0.7601. So it's 0.71.
It's 74 actually.
Oh, 74, yeah. So let's change that. .64. Number 5. A mile runner's times for the mile are normally distributed with a mean of 244 seconds and standard deviation of 5. So mean is this and standard deviation is that. What's the probability that a given run, the time will be 240 seconds or less? So less than 240, guys. Okay, that should be very straightforward. Okay, what would be the first number here? Can someone tell me what's the lower bound?
Negative 1,000,000.
Yeah, you got it now. And then what? 240. And then the mean. Don't put 0.1 here. It's about x, not z. And then 5. That's it. And just to get the answer. Normal CDF. Students always ask me, we get confused. When do we use normal CDF and when do we use inverse norm? Normal CDF, you use it to find the probability. If he's asking you to find a probability, then it's normal CDF. Now, if he gives you the probability and he asks you to find a z-score or x value, then you use inverse norm. Which one do you use more? Definitely the normal CDF. So 240, and then the mean is 244, and then 5, guys. So 0.2119. Okay. 6. On a standardized test, the scores are normally distributed with a mean of 400 and a standard deviation of 80. What score must be in the 80th percentile? You see, percentile means he gives you probability, guys. So that means he wants x. We just agreed in question 4. If he gives you the percentile, you put it first, 0.80. And he gives you the mean, which is 400. He gives you the standard deviation, 80. Now you notice, guys, in number 4, we put 0.1 because he says, what's z-score? Here in number 6, he's asking what's the x value, what's the original score. Then he must have a mean and a standard deviation. And let's see what would be the score. So 0.80, 480, 467.33. Number 7, suppose the diameter of a certain car components follow the normal distribution with the mean of 10 and standard deviation of 3. Find the proportion of these components that we have diameter larger than 13.4. The reason why I put the proportion, guys, to tell you, if you see the word proportion, it means probability. So if he asks you probability, or if he asks you what percent, or if he asks you what proportion, it's the same question. I reworded the question. If we randomly select one of these components, what's the probability that its diameter will be more than 13.4? So more than, you put X, more than 13.4. And would the students help me out with the 4 components here? What would that be? What's the lower bound, guys?
13.4.
Yeah.
And then a million.
Yeah. Then you put the mean and standard deviation. Here you go. Second, and distribute. 13.4 million, billion, 10, 3. I got 0.1285. Number 8. Find the 25th percentile or first quartile on the normal distribution of X. Okay. Well, that's wrong here. So he gives me the probability and he wants actually Z. Sorry, I needed to fix this one. So what would be the Z score that corresponds to 25th percentile? 25th percentile, guys, will be this. This is the 50th, so 25th will be somewhere here. This is 25%. He wants the Z score. So it's inverse norm. As I told you, when you have percentile, guys, you put it, this is the area to the left, and then you put 0, 1. And let's see, what would that be? So if you are in the 25th percentile, means 25% are less than you of whatever data. So it would be second distribute, inverse norm, 0.25. It would be a negative answer, negative 0.67. All right. Now we're gonna come to this question, which is very similar, guys, to your assignment. We'll see that. So please pay attention to number 9. This is a review of the entire chapter, actually, number 9. Suppose the weights of navel oranges is normally distributed with the mean of 8 ounces and standard deviation of 1.5 ounces. So mean is 8 and standard deviation is 1.5. And let me just get the assignment and show you, compare the questions in both. Okay. Question A. If you randomly select a navel orange, what's the probability that it weighs more than 11.5 ounces? Okay, let's look at the assignment. What is the probability that one randomly selected adult male will weigh more than 190? Very much the same question, guys. Here it's about weights of males and the other one weights of oranges. So it's exactly. Part B here is part A in here. So you start with X more than 11.5 ounces, and that will be 11.5 lower bound, a million, and then 8, and then 1.5. When you do your assignment, what is the probability that one randomly selected male adult will weigh more than 190? You're going to start with probability of X more than 190. Then I want you to write normal CDF, put the 4 arguments, and give me the answer to 4 decimal places. So make sure all answers are to 4 decimal places. All right, so that's how you do this one. Part B. What proportion of oranges weigh less than 9.7 ounces? When I say, guys, a proportion, it means what is the probability that an orange will weigh, an orange selected at random will weigh less than 9.7 ounces. So it will be.
Wait, so why did you put those numbers on A, those specific numbers?
Because it says more than 11.5. More than 11.5, you put 11.5 lower bound, 1 million upper bound, the mean, which is 8, and the standard deviation is 1.5. Yes?
Yeah, that makes sense.
Yeah. Less than 9.7 ounces. Same thing, guys. Normal CDF. And I'll show you a question in the assignment with less than. You put negative a million. Just follow the same approach. Exactly. 9.7, 8, and then 1.5. You want to see the question with less here? What is the probability the randomly selected male will weigh less than 185 pounds? And then you do the rest. You just have to do this. Okay. You know what the next part is going to be in between. What proportion of oranges weighs between 9.2 and 11.7? So he wants X between 9.2 and 11.7. And you want to see a similar question in the assignment? What is the probability that one randomly selected male will weigh between 175 and 200 pounds? So C is similar to C here. And how do you do this? You just do normal CDF. You put 9.2, you put 11.7, and you put the mean, which is 8, and the standard deviation. D. Find the 80th percentile of the distribution of weights of oranges. The question can also be asked as follows. Find the value of X below which you find the lightest 80% of all oranges. So when he asks you for the X value, it's an inverse norm, guys. He gives me the percentile, which is the probability 0.80. And I know the mean, which is 8 ounces, and the standard deviation, which is 5. Let's see. Second, inverse norm, 0.8, 8, 1.5, and it should be 9.26 ounces. All right, if you ask me, okay, D, there is no D. I didn't put a similar to it, but let's see now, next one. E, pay attention to this. This is section 5.4. If 9 oranges were randomly selected, so N is 9 now. What is the probability that their mean weight is less than 11.2 ounces? So guys, it's not about X anymore. It's about X bar, the mean, 11.2. This is the central limit theorem. That's the applet that I ran last time, and I had you watch it and write conclusions. Okay, can you guys help me out? What would that be? Normal CDF. What would be the lower bound?
Negative a million.
Negative a million. Upper bound.
11.2.
Mean, that doesn't change. It's always 8. And what about here? Standard deviation.
Here the sigma will be the 1.5 divided by the square root of n, which is 9.
Exactly, guys. That's it. And you ask me why again. The question is not about one orange. If the question is about one orange, if x is 1, you should randomly select one orange, it's just sigma. When he uses a sample size, he's gonna ask you about the sample mean, about x bar. And when the question is about x bar, the standard deviation changes, guys. It will be smaller. It will be the original standard deviation divided by square root of the sample size. Now, let me show you a question similar to E in the assignment. So this is a probability of X between 175 and 200. Let me just do that. Okay, look here. D. Suppose that 25 adult males are selected. So N is 25. What is the probability that they have a mean weight of more than 190 pounds? So guys, you'll be answering the question about X bar here. So just remember, when you run your normal CDF, make sure that your sigma will be sigma over square root of n here. There's another one. So that's section 5.4. And that's again section 5.4. If 17 oranges are randomly selected, what's the probability that their mean weight is more than 12 ounces? So it's X bar more than 12 ounces. How likely it is to find, just 17 oranges with a sample mean more than 12? Probably it's very unlikely, but let's check. Normal CDF. 12 is the lower bound, 1,000,000 is the upper bound. And then the mean is 8. And look, guys, the standard deviation is going to be 1.5, but not divided by square root of 9. Here, n is 17. So it will be square root of 17. And look, guys, there's another question here. Suppose that 36 adult males are selected at random. That's n. What is the probability that they have a sample mean less than 168 pounds? This is just like part E. So that is E and that is F and the number 9. Okay, let's find the answer. Second, distribute, normal CDF. Okay, we want more than 12. So 12, 1,000,000. Mean is 8, standard deviation 1.5 divided by square root of 17. And again, here's how I enter square root of 17. I press the second key, then I press x squared. I put 17 in close parentheses. Okay, look, guys. It's 2.07 E minus 28. E minus 28 means you have to move the decimal point 28 times to the left, which is 0. Just your answer is going to be 0. That is the answer. It's almost impossible to pick up 17 oranges and find out that their average weight is 12 ounces, more than 12 ounces.
Mr. Bazzi,
Yes.
if I get the -3 for -4 for 0, so then I can round it and I may get like 0.009 or something like that, right?
Yeah, if you got 4 zeros, yeah.
Oh, okay.
But more than 4 zeros is going to take you to 0 when you round to 4 decimal places.
Right. Thank you.
Yeah, that's 0. That is obviously just like winning the lottery. Even it's worse chance than winning the lottery. It's too many zeros there. Okay, G. What would be the minimum weight of an orange that is places in the top 10%, guys? 10%, top 10% of weight has to be on the right. So this orange right here. Okay, and that's a 10% area. We need this X value. So what is it gonna be, guys? Inverse norm. Okay, on my calculator, I have to enter the area to the left of the target. So what would be the area to the left of my target, guys?
0.90.
Yeah. And then 8 and then 1.5. We're done with the samples here. So just use 1.5 again. Inverse norm, we just use 1.5. Okay, so 0.98, 1.5. You get 9.92 ounces. And let me show you the last question on the assignment, which is similar to this. What weight would place an adult male in the top 15%? So I'm just going to give you that hint, guys. I'm going to sketch it for you. And top 15%, guys, is going to be right here. And if this is a 15%, guys, you know this is what? The area to the left is 85%. You just follow for F here. Just follow exactly the same thing as I did for G right there. You get the answer. So that's the assignment. Number 10, a firm's marketing manager believes that the total sales for next year will follow the normal distribution with the mean of 2.5 million and a standard deviation of 300,000. What is the probability that the firm's sales will fall within 150,000 of the mean? Do you guys understand what does that mean? If I say 2.5, $150,000 within the mean, what does that mean? It's either 150,000 above the mean or 150,000 below the mean. So what you have to put here, the reason why I put this question here, just to explain what the word within to you. So just take 2.5 million and subtract 150,000 and take 2.5 million and add 150,000. So it will be 2,350,000. And here, if you add 150,000, will be 2,650,000. And now you can just easily use normal CDF, guys, for this one. Normal CDF, 2,350,000. 2,650,000. The mean is 2.5 million, right at 2,500,000. You have to put it in thousands because this is in thousands also. And then 300,000 for the standard deviation. And then you can compute the answer. MB, last one. Determine the sales level that has only 9% chance of being exceeded next year. So what would be the sales level that would put someone at the top 9%? Once he gives you guys a percentage, that means he gave you the probability. So that's a 9% here. How would I find X? Can you guys help me? So that will be inverse norm. And what would be the 3 argument? So if this is a 90%, guys, you agree with me that the area to the left is 91%. So it will be what? 0.91. For students who have the right, left, center calculator, you can put 9% and just select right at the bottom. That will give you the answer. But if it doesn't, you have to specify the area to the left. So that will be 0.91. And then the mean, guys, is 2,500,000. And then the standard deviation is 300,000. And let's see what this answer is. Second, distribute inverse norm, 0.91. What was it? 2,500,000. Count the zeros properly. Don't miss any zeros here. And then 300,000. And then paste. And I got 292,902 and $227 if I want to round it to the nearest dollars. $2,902 and then 227. Okay, so
Mr.
that,
Gazi,
yes.
can you please go back to number 10? How did you get the 350,000?
Oh, it says, what's the probability that the firm's sales will fall within $150,000 dollars of the mean? For example, if you have an appointment with me, let's say at 2 p.m., and I said it's okay, you know, just to come to my office within 10 minutes of the appointment. What I mean by that, you can come 10 minutes early or you can come up to 10 minutes late. So within 150,000 means you take the mean and subtract 150,000 and you take the mean and add 150,000, and it's between those two values. And what we did here, we took the 2,500,000, we subtracted 150,000, and we took 2,500,000, we added 150,000, and we ended up with those two values.
Oh, so the 2.5, it's 2,500, then you make minus 150,000.
Exactly. So if you want,
Because I get it wrong. Yeah.
Yeah. 250.
So 2,500,000 minus the 150,000.
Exactly. And
Thank
this
you.
one will be 2,500,000 plus 150,000. All right, that's what we did. All right, so